Now, there is a particularly important relation between slopes of lines. If the slope of two lines, M1 and M2, are equal, then we say that the lines are parallel, like so. But if their slope multiply to -1, then we say that the lines are perpendicular, as in this example. But can we figure out a way to understand why that is so? Well, suppose this point is on both lines. If we move to the right by unit distance 1, then the first line with assume the slope that's positive will rise by M1 units, because rise upon run equals to M1, all right? And the distance we move to the right is just unit. Therefore, the rise is exactly M1. Whereas the second line that is hopefully perpendicular to the first one is going to descend by an amount, the absolute value of M2. And this is going to be minus M2, because if M2 is decreasing, then the length of this side must be the negative of that. Now, if the lines are perpendicular, then the sides must be perpendicular as well. That's a right triangle. In particular, this is also a right triangle, and this is also a right triangle. So this side must be 1 plus M1 squared. This side must be 1 plus minus M2 squared, which is just M2 squared. Now, this side is actually M1 minus M2. So, by the Pythagoras theorem, this right triangle must have sides that satisfy the Pythagoras theorem. In particular, this side squared, which is 1 plus M1 squared, and this side squared, which is 1 plus M2 squared, must be the same as this side squared, which is M1 minus M2 squared. In turn, if we expand, we get 1 plus M1 squared, or just 2 plus M1 squared plus M2 squared, plus M1 equals M1 squared minus 2 M1 M2 plus M2 squared, where obviously the M squareds cancel. So we get 2 equals to minus 2 M1 M2. So 1 must be, or minus 1 must be M1 times M2, as follows.